Turning tools should operate within a specific parameters range, and we will discuss about them here. First, some definitions. Spindle RPM. RPM stands for revolution per minute. Therefore, spindle RPM means when a lathe spindle is rotating, how many revolutions it's making in a minute. In general, when the RPM is higher, the surface finish is better. But on the other hand, higher RPM will result in tool wear and possible vibration. In manual lathe, operator is setting the RPM to a specific one using spindle RPM adjusting handles. Now, the cutting speed. Cutting speed is the relative velocity between the tool and the workpiece surface, and it is represented by meter per minute or feet per minute. It depends on the units that you are using. This parameter has a bit abstract meaning, but it is very important in CNC lathe operations. There is a relationship between cutting speed and RPM, and it is defined by a formula here. You can see two formulas. One is calculating cutting speed if units are in millimeter, and the other one if they are in inch. As I said, in manual lathes, operators set the RPM. However, in CNC lathes, most of the times a programmer, instead of defining the RPM, is defining the cutting speed. For example, here you have a sample G-code line. By the way, G-code is the language that is used to program CNC machines. This sample G-code starts with G96. In most of CNC machines, G96 means that cutting speed is constant, and it takes the number after S as cutting speed. If we had G97 instead of G96, then the number after S would represent RPM. Here we have cutting speed constant and 300. M03 means that spindle will rotate clockwise. Here we have cutting speed constant, so when the diameter where tool is in contact with workpiece is decreasing, then the CNC machine increases spindle RPM. And when the diameter increases, it decreases the RPM. In this way, cutting speed stays constant, and this results in uniform surface finish in small and big diameters. Like RPM, if the cutting speed is higher, the surface finish is better. However, this might result in excessive tool wear. Feed is the speed of tool movement, and in lathe operations, it is defined by a distance that a tool moves per revolution of the spindle. Therefore, in lathe CNC, G95 is used, which means feet is defined as millimeter or inch per revolution. On the other hand, in mills, usually G94 is used, which means feet is defined millimeter or inch per minute. In this sample G-code line, we have G95, which means feet is defined in millimeter or inch per revolution. G01 is CNC command which makes a machine to move to a coordinate in a defined feet. X and Z define the coordinates of the endpoint, and F defines the value of the feet. Higher feet can result in shorter machining time or smaller machining chips, but excessive feet rate can cause insert breakage, high machining forces, and vibration. The cutting depth or depth of cut, which is usually shown in catalogs by AP, is a difference between the uncut and cut radius of workpiece. Higher depth of cut can shorten machining time, but it can also increase machining forces and vibration. RPM, cutting speed, feed, and depth of cut are the main cutting data that you will define in a CNC program. To find out what you should set for each parameter, you can go to Insert Manufacturer Catalog, or usually at the back of Insert box, you can find some recommendations. For example, here you can see back of Inserts box picture. CCMT 060202 is insert code in millimeter, and CCMT 21.50.5 is insert code in inch. Then there are some recommendations for P and M group of materials. P stands for steel and M stands for stainless steel. Now you can see some recommended range for F, which means feet, and VC, which means cutting speed. If it is better that you take the middle value of the range as initial try and adjust it according to your fixture, machine condition, vibration, and other things. At this point, I want to talk about material groups again. You can see on the picture of inserts box six group of material. P group stands for steel and it is shown by blue color. K stands for cast iron with red color. M for stainless steel with yellow color. N for aluminium with green color. S for heat resistant alloys such as Inconel and titanium alloys. And finally H for hardened steels. Also you can see two circles below P and M. This means that this insert is suitable for steel and stainless steel materials. Okay, this session was quite a short one. In next session we will start talking about milling tools.